We have 2 more talks for you today. It's been fantastic security, identity, and privacy mini-conf so far. I'm looking forward to the last few. No, not because I want them to be over. I'm actually genuinely interested. But then, of course, we can also go for beers afterwards, which is always a highlight of any event. Without any further ado, I've been asked to make a quick introduction. So I'm going to hand you straight over to C Cohen, who's going to be talking to us about improving the security of your code with free analysis tools. Thank you, Jason.
All right, thanks a lot. Good afternoon, everyone. I guess it's afternoon. For me, it's like almost 1 a.m. in the morning because I'm from near Washington, D.C., so hopefully I had enough coffee to get through this with you guys today. If not, if I fall asleep, I apologize in advance. But anyway, thanks, of course, to Ben and Aaron for having me and the whole LCA team for putting on such a great event like they always do. So the talk is going to be a kind of just an intro into ways that you can improve the security of your source code using some free analysis tools that are available. This is kind of geared towards maybe some new developers or maybe developers that aren't really into the security so much yet. So if you've been around developing for a while, you've probably heard a lot of this, but so I apologize in advance if it's boring to you. But so just a quick little bit about me. I work for Hewlett-Packard Enterprise. I work in our security lab. We do defensive security research, trying to improve security of our products, particularly at the hardware level, and trying to add value to the stack from the hardware up. And the other thing I do part-time, I'm an adjunct professor of software development and security at the University of Maryland. I've been doing that now for about 2 years. It's been a real rewarding experience to try to kind of give back a little bit and try to help the next generation not make the same mistakes that we all have. And if anybody has a lot of experience and has free time, I highly encourage to look into ways that you can do similar things. Like I said, I'm based near Baltimore, Maryland, not too far from DC. And I've been doing this for about 18 years now. I've been at Hewlett-Packard for since 2007, and I've worked for a couple defense integrators before that. So for today's agenda, like I said, I wanted to kind of give a starting point on some of these topics. It's definitely not all-inclusive. Don't have enough time. Probably don't have enough time even for what I have, so certainly not enough time to cover everything, but we'll get through what we can. And so I'm going to start with a little bit of a motivational factor, not that you need it after some of the talks we've had today, but we'll start there, and then talk a little bit about secure software development lifecycle, just briefly, how to use it. I look at that as a tool, even though it's more of a process. And then some considerations for security-minded developer. We'll talk a little bit about security coding standards, that kind of thing. And then we'll get into some tools, mainly for today, static code analysis tools. I'm going to show you 4 different tools that you can use today that are free to open source. And then another big topic right now is dependency management, particularly in this world we have using containers and that sort of thing. One of the things that crept into the top 10 vulnerabilities recently is using dependencies with known vulnerabilities. So show you a couple tools that you can use to keep on top of that. And lastly, enough security wouldn't be complete without peer review. So I'll hopefully, if I get to it, show you a quick tool on how to do that. So in case you didn't notice, we still have security challenges. And I selected just the random, well, not quite at random, because I thought that each one kind of demonstrated a little bit of a trend that I see, but a couple headlines over the past few years. This SCP vulnerability that came out recently, 36-year-old code, demonstrates something we've seen since Heartbleed, which is, there's these code bases that we assumed have been pretty well looked at, pretty secure. Researchers are really digging into that and finding that maybe that's not such the case. The ransomware has become obviously an epidemic. It's impacting people's livelihoods. This company had to shut down due to a ransomware attack. The next one was particularly interesting to me in that my wife and I own a general aviation aircraft. My wife's a pilot. And so researchers are looking at things that we didn't really consider for security before, things that maybe physical access attacks weren't really in the mindset of the developers. And with this particular one, the DHS actually issued a warning about improving security at airports because of this. general aviation airports, that is. This ThunderClap thing kind of shows you the dangers in peripherals and memory access that we're seeing now. In a firmware vulnerability is something that in the past we really didn't give too much thought to, but become a much bigger, we realize it's a pretty big attack surface as some of the other application layer stuff, it becomes more defended. And attackers are realizing they can hide in firmware and maintain persistence, so big thing. And this ASUS update thing was kind of interesting in that it shows you the lengths APT can go through. You know, they compromised this system only to install malware on 200 machines. So I don't know, if it was ever attributed to a particular nation state, but it's a lot of effort to go through to attack 200 people. And it also shows you that a security tool can be turned into here. They're trying to provide updates, keep the systems up to date, and it's turned against the users. And then, of course, IoT is a disaster with you can see this headline about cars with hard-coded password. This stuff should be really easy to fix. It's what these type of tools that I'm going to talk about are going to help you help new developers prevent. And then the last thing here, of course, ever since Spectre, we're still hardware is a new attack surface. It's gonna be bigger and bigger, of course. And there's increasing consequences to failed security. I'm not going to dive too much in this, you guys know. Governments now are imposing pretty large fines for data breaches. What's going on in the European Union rules that they've brought out recently. Stocks, even at the mention of a possible data breach, are highly affected. Not to mention, of course, the aforementioned fines affecting the stock prices. Small businesses, of course, can just go out of business with a ransomware attack. And then, again, ransom, big deal, mainly because, you think about these are cyber crime organizations, usually based out of places like Russia. You think of a young, talented developer coming up there, they can get a job, maybe make a couple bucks, or they can get into ransomware and become a millionaire, maybe. So it's a big motivational factor there. And, in life, of course, like I said, we got software going to automobiles that we really, aircraft, medical devices, and it's a big deal. Another problem is we've got these advanced threats, like I said, they're very hard to detect, they're hard to get rid of. This just talks about dwell time. It's dropped recently, probably because we got better security tooling than we used to have with security event management type stuff. But we're still looking at 110 days that these adversaries are dwelling on networks. And of course, the sophistication of attackers in terms of breakout time is pretty impressive. These are from CrowdStrike, these numbers, but they've estimated that once they make an initial breach, these adversaries want to spread out through the network, gain other footholds so that it can't be easily eliminated. And you're looking at less than 20 minutes. So unless you can detect the breach in less than 20 minutes, you got problems. And then, of course, there's financial motivators and these security researchers that have 0 days. You can easily make quite a bit of money on this. Fortunately, on the bright side, we have some pretty good bug bounty programs now that kind of help counteract it a little bit. And the main attack vector, is usually the application. And in the application, we're including, of course, the user. Typically a big weak point. Phishing vulnerabilities, are easy way for an adversary in, but also badly configured applications with known vulnerabilities in their components, et cetera. This recent TikTok vulnerability was kind of a combo. They used phishing to get somebody's phone number, and then they could exploit an application vulnerability to send them a link with some, malformed URL kind of deal and access their account. So. This chart I'm not going to get into, but just to belabor the point I was making about the known vulnerabilities, this has been in a study from last year, I believe, showed that there's just such a large number of software packages out there that it still have known vulnerabilities. And another thing that I highlighted there in red that I thought was kind of interesting is, according to their survey at least, that only 3 in 10 open source maintainers consider themselves having high security knowledge. I don't know what high security knowledge is. I'm not even sure if I have it, but you have to, it'd be a jack of all trades these days when you're in this business, unfortunately, and we all have to get better at this. So what can we do? This all sounds pretty bad. So, there's this whole circular cycle that these organizations have to put in place now. It used to be you might have 1 or 2 guys on your security team. Now you have this whole bunch of nonsense. Well, I say, don't forget about that. But what we really need to do is fix the code. And you know, we do have tools to make things better, and I'm not suggesting we can fix everything. I mean, some of these tools that like I've mentioned, for instance, Coverity, that's free or open source, has been in use by Linux since I believe 2006, and clearly there's still vulnerabilities in Linux. So, you know, but it does make it harder, and certainly for less complicated applications, it makes it significantly harder. So yeah, how about some good news, right? So we have made a lot of strides actually ever since. You know, I think Harpley was a big wake-up call. You know, the core infrastructure initiative. A lot of companies got together, said, "Hey, let's put some money towards this problem, try to make things better." GitHub, to their credit, has brought out some good resources. They have a security lab. They've just invested in a new security tool that's available to developers now. There's so many tools out there that you can use if you know about them. Microsoft, they put out a lot of good research on their security development lifecycle that a lot of big companies like HP, for instance, have taken under and advisement and used. And you know, in university programs, I used to always say, you get developers come out, they barely know how to code a little bit, and they certainly don't know how to make secure code. At least in the program that I've been working in, we now have a mandatory security programming class, at least to try to give them an idea of what they're doing wrong, and at least give them a starting point on that journey. So our first free tool that I'm going to briefly talk about is more of a process, and that's using the security development lifecycle. So if you see from my image here, so this is an example of a failed security mechanism, right? You have a gate with no fence and don't let the cat out. And that's what we're trying to avoid by taking some reasonable thought on when we're designing software. Now, if you're working with an existing project that's been around, like that 35-year-old software we're talking about, obviously it's hard to go back to requirement stage and all that stuff, but you can implement bits and pieces of it. And even if you're doing a personal project and throw code out on GitHub, at least put a little bit of thought into this and what you can take out of these concepts. And I'll just go through the main ideas real quick. So starting at requirement stage, this is when you want to define, like, okay, let's think about the security features we're going to have. Do we need to deal with authentication? Can we not deal with authentication? That would be great. What kind of, do we need to be FIPS compliant? This kind of thing, write them down. So we're not retrofitting libraries later on. In design phase, this is when, primarily you want to look at system boundaries, right? What data is coming in and out? Are we dealing with network traffic? Are we dealing with user input? And these, we want to document that, threat model if you want to, but that's the part when you get to coding that you're going to want to put extra eyes on, right? And then of course coding, you want to adopt a secure, basically just any coding standard, so it makes it easier to review. Do all the best practices with testing, and of course peer review, and then leverage the automated tools, the static code analysis stuff, the dynamic analysis stuff that's available. Deployment. You want to be able to deploy software and secure by default. This has been a big problem with a lot of projects. You roll it out, you grab the Docker container, and it's just not configured securely by default, and that's how people tend to leave them, okay? So if there's ways to get it secure by default, do it. If not, at least provide really good documentation on how to make it secure. And of course, be ready to support your software, because there's going to be a need to update a component or something like that, and you want to make it easy as possible for people to get out the patches and to be notified of that. And I'm not going to dig into this, but this is Microsoft's process. I recommend going on their site and clicking through all of these if you're interested in this stuff. They give some actually pretty good information on how to do threat modeling in particular that is pretty neat. So definitely take a look at that. An idea here is you want to just kind of drive that security mindset as early into the project as possible, because that's when it's easiest to do, frankly. As you get towards the end, it's obviously a lot harder to and more costly to mitigate. So security-minded development. This is a famous picture, right? So you got some sort of guard gate, right? And it's like, no fence or anything, so you can ride around it. A lot of people know about security features. They know they need passwords, they know they need this or that, but they don't really know properly how to implement that. So education is a big part of that, and coding standards, right? And I don't care which standard you pick. So if you're in a particular field, if you're in automotive or aerospace, there's recommended standards or required standards for a lot of the stuff that you can look into. CERT puts out standards for Java and a couple other C, a couple other languages. So definitely know, based on what you're developing, what's the proper standard to use. And some basics. Can't get into all the details here, but and these of course vary from platform to platform. You know, at a high level, right, we really want to look at input, output, particularly input from external data sources. How are we validating all of these? Are we properly kind of documenting these ins and outs? We want to do least privilege access by default, of course. We want to actually use our compiler and not ignore those warnings that spits out. And as shown in this picture, we want a layered defense strategy as well if possible. So, you know, the car got past our guardrail there, but it's smashed by the cement truck. And so, you know, a lot of times you'll use a framework that validates data for you, which is great, but if you can afford it from a computational standpoint to basically do additional validation of data, you know, do it. It's no harm in it. Except for maybe performance. And don't be in the business of things you shouldn't be into. I mean, and there's really not a lot of reason to do authentication anymore. There's not any certainly not any reason to write your own crypto unless you're a cryptologist. And then, you know, I see this all the time with students actually is, you know, we'll have an assignment. It's like, okay, implement a web page. It has a database with a username, password. And they'll use an example that they probably found on the internet. It's got they're using MD5 hash or SHA-1 hash, and it's just not sufficient anymore. So if you're going to do crypto, understand what you're involved in, right? You know, you need to use either Bcrypt or Argon or whatever the current best practice is for that. Some good resource out there. This gentleman, David Wheeler, he's got a good ebook. He's the guy who wrote Flawfinder, which is a tool we're going to talk about shortly. He's got I recommend his book. It's quite interesting. And like I said already, there's a CERT standards for programming that are good to familiarize yourselves with. Just an example of poor coding practice. I just saw this the other day. I've taken a class, and they required us to sign up for this book portal. And you can see there that I can't put any special characters or spaces in my password, which begs the question to me, how are they storing my password if they can't accept special characters or spaces? So just get out of the authentication business. No reason you can't just tie this in with Google or whatever other authentication source you can use these days. Okay, and now we'll get to static code analysis tools. So real briefly, so what is static code analysis? Well, it's really just a process for looking at code without executing it, right? And it's not a new idea. It's been around, I don't know how many years, but since, I guess, Linter for C, right? But the idea of using it for security, I guess, is a trend in the past couple of years. That all said, you know, it's not perfect. If you remember your computer science, you might remember the halting problem from theory of computation. And that says you can't determine if a program exits in polynomial time, right? So you can't really do full static code analysis in polynomial time. So these scanners use a number of different techniques, and the only reason I mention it is because, you know, it's good to know what your scanner is using. The simplest tools, of course, are kind of glorified grep. They're pattern matching. Your more complicated commercial tools often are doing pretty complex stuff where they're interjecting themselves into the compilation process and building control flow graphs and building data flow graphs and trying to figure out, okay, is it possible to get to some obscure part of execution flow through the control flow, or is there a tainted source of data that's going to a sink that's not being filtered in some way? And all the tools generally give you some sort of report at the end. They'll also provide a way to filter false positives out. They vary in ways to do that. When you're thinking about a tool, you know, what considerations? Obviously, language support. The best practice, of course, is to use multiple tools if you can. And remember, a fool with a tool is still a fool, and that means you know, a tool only gets you so far. You still it won't get you through architectural issues. It's only looking at the code, not the architecture. So you know, you still have to be trained and have peer review and everything else. And the best thing to do is really to integrate your code analysis into your whole process. So you can do this a number of ways. If you have a project you're using continuous integration, you can certainly, most of these tools can be scripted into Jenkins or whatever you're using. If you're just using GitHub, you can, some of them even plug in when you push do a pull request, it'll automatically run a tool. So, and if you just want to use it offline with your IDE, some of them have plugins for that. So just think about ways you can do it early and often, because that's when they're most effective. There's also commercial tools you can do a one and done, pay for use. I don't really like those because you typically you're going to wait for the end of the project to do it, and that's already kind of going to cost you more to fix that stuff later. So our first tool is a simple tool called Flawfinder. It's by this guy Dave Wheeler I mentioned. It's a very simple install. You can install it with pip install Flawfinder. And it, as he calls it, it's a kind of naive tool in that it doesn't do data flow analysis or any sort of sophisticated analysis, but it does do some, looks at functions in C, C++ code that are known to be vulnerable, not vulnerable per se, but risky, I say. And it'll look at the inputs, and if those inputs are literals, it may ignore them, but if they're variables, then it'll flag that stuff as something you should look at. So let's do a quick demo of it. Hopefully this will work. Okay. Okay, so I have a C program with a very simple buffer overflow, and it's using gits, which of course is not a good idea. So I have that there. I'm going to run the tool against that, and the other file in that directory is actually the file that has Heartbleed in it from the vulnerable version OpenSSL. I just thought it'd be interesting to run the tool against and see what it says. Okay, so you run it. You can generate this nice HTML report. You can see there it did detect that we got a possible buffer overflow vulnerability. It gives you a nice link to the CWE, so you can say, oh, well, how do I fix that? Let me see what's going on. And then if I scroll down here, I also looked at what it came up with this particular OpenSSL file, and it did, there on 1480, did say, hey, this memcopy operation might not be safe. In all fairness, because it's only looking at this one file, it doesn't know if that data is being filtered somewhere else. So my point here is that it's going to direct your attention to parts of the code that you should look at, but it doesn't know everything because it's a fairly simple tool. Okay, our next tool here is Python Bandit. This is purely for Python code. Of course, Python is a pretty secure language out of the box. So it's, if you could write something in there versus C, I certainly would do it. But nevertheless, there's still a lot of risky functions you can do in Python. If you're doing it for web development, you can certainly have unfiltered input, that kind of thing. You can use bad crypto. So that's the kind of thing that this is geared to detect. It's another simple install, runs from a command line. You can filter out false positives with it using some simple directives in your code. And it doesn't do data flow chain analysis, but it does build an abstract syntax tree, and so it does some fairly complex analysis on the code. And let's run it. So this, I'll do a kind of a cheap demo here. This is the code that it came with in its examples directory. So here I'm running it against this one file and just kind of showing you the output. You can see how it highlights different parts of the code. And probably more useful is you can run it and generate a HTML output file that you can then kind of go for a little bit easier. So here I'll run it against the entire directory and see what it does. All right. Okay, and here you can see it's generated a file for us that we can then explore and see vulnerabilities in all of our files in the directory. And it also gives you a nice link to understand what plugin it got triggered by it. Another thing I didn't mention is that you can actually write your own plugins for this too. So if you are looking for something in particular in your code, you can write your own Python library for it. All right. So getting on to something a little bit more complicated, Codacy. This is actually free for open source now. It's a commercial tool. Its strengths to me is it supports a lot of languages. It gives you a nice web portal. So you can, if you've got a big application or you've got a lot of different repositories, it gives you insight into all of them kind of at once. It automatically detects the language that you're using. On the downside, I'd say that it's more using tools that are available, kind of open source command line tools. So it's not doing any sort of real deep analysis because it doesn't have any mechanism to do compiled, to interject into compiled code or anything like that. But nevertheless, it's still pretty neat. I'll show it to you here real quick. First off, if you're using GitHub, it's pretty easy to set up. All you have to do is authorize to log into, access to your repository, couple clicks away, and then before you know it, you have something like this, which is a view of all the repositories that you have. Let's see here to start. Okay, so the first thing I'm going to show you is the same bandit example, the example from the bandit directory, and here you can see it's kind of giving us a little bit of a portal view into it. You can kind of click through the various code hotspots, and you can click on that security tab there, and you'll see kind of organized by types of vulnerabilities. So here you can see our use of insecure ciphers that it picked up on. Again, all it's really doing in the back end is utilizing that bandit tool, but it's giving you kind of a different way of looking at it. If you're managing a project, it kind of gives you a good high-level view of that. And let's see here. And by the way, so here's all the various code patterns that it's using for this particular project. So it's detected that in this folder I've got PHP, I've got C, and these are the various plugins that it's used. And some of these are tunable, so you can go through and click through different things that you may or may not want it to try to detect, so you can kind of fine-tune your results. And also, see here if I got it. Okay, so and also that same C file that we showed you earlier, it did also find the same, not surprisingly, the same vulnerability in that file, mainly because it actually just runs Flawfinder in the background for you to do that. So one thing this doesn't show you, I don't think I have time to sit here and wait for it, but I have a Java project in here that has I'm using an insecure password function. I'm just basically using a SHA-1 hash for a password. And that project there, it's called PickOps. It doesn't show any security vulnerabilities, so it didn't get everything. Okay, so another tool that's very similar to this one is Sonar Cloud. This tool is also free for open source. It sets up pretty much the same way as if you're using GitHub. The last one I showed you. This one is a little bit more complicated. This was also previously known, it was still known as SonarCube, which is basically the version you can run offline. So if you're not connected to GitHub and that kind of thing, you can, for free, also get the SonarCube. They have commercial versions of the tool, too, of course, with support and that kind of thing. It does have its own detection libraries. It supports 20-some languages. It does also interject itself into compiled code. So you can, I'll show you how that works in a second here. So you have the same thing, like I said, to set it up, pretty simple if you're using GitHub. Here, I'll just show a second of this. This is the, you have to run this kind of Sonar scanner with basically like a token for your account against whatever source files you wanted to analyze. And based on, it's not doing anything, of course. And once that's complete, you upload that to Sonar Cloud, and it can look at your compiled code for you. So, quick demo of this. This is the interface for the Sonar Cloud. Kind of when you log into it, you see this. Yeah, why isn't it playing? Is it going now? Okay. So starting here, I'll start with my C file that I showed you earlier. You can see right there it's detected the vulnerability. Of course, it's done it with its own scanning engine because I ran that compiled tool against it. But it gives you similar results. One thing that's kind of cool here, I think, is you can click on, it kind of helps with code review as well because you can click right on it and you can add comments to it. And you can even create pull requests, that kind of thing, right from the tool after you get it all linked into GitHub. So pretty neat. wish I had a way to skip ahead on this, sorry. Doesn't seem like I do. Another thing at the bottom there, it does show you, another nice thing, it actually gives you examples of how to fix the code. It doesn't always do that, but kind of nice feature as well. To help speed up your ability to fix it. I ran it also against that same Python code base. It's using a different mechanism to do the scan, but you can see it also discovered quite a few vulnerabilities, not surprising. Gave me a E rating on my code base, which is good. And the last thing I did is I also ran it against, you can see here it's showing the same kind of vulnerabilities as the other tool. I also ran it against my Java project, and I was happy to see that it did detect my use of an insecure crypto function for a password. And like I said earlier, if you make once you get it integrated and you put a pull request in, it automatically will scan the request and give you kind of a readout of what it thinks about the quality of that request. Now, Coverity, probably a lot of people have heard of. It's been around for a long time. A lot of big open source projects use it. If you're not using it, you definitely should. It's a commercial tool as well. It's supported by Synopsys now, and it supports quite a few languages. They've done a lot of work to try to reduce false positives as much as they can. They've actually wrote a pretty good article about what they did after Harpley, because they realized the tool would not have detected that. And they created some new heuristics to try to detect that kind of vulnerability in the future. So they're always improving it. So in order to get an account with Coverity, you have to have a public project. You have to apply for an account. You have to have also a license that satisfies what they're looking for. Basically, any of the open source licenses work. And then then they'll grant you an account. And then you also have to run this tool just like the Sonar stuff that I showed you, which is generating a analysis file that you then go and upload right here in your project. And once you upload it, it may take a little while depending on the size of the project. And next thing you know, you should have some information. So when you log in, you see something like this. All the projects that you have, then it'll show you all the lines, kind of statistics for the project. Probably more interesting, it'll give you some of your top defects, and then when you click on the view defects, it'll show you a detailed view of everything that it found. It's a little bit clunky, honestly, but you kind of get used to it after a while fiddling with it. So the first thing I'll show you here is the C vulnerability. Now, one thing here, it'll show you different snapshots. So, I've uploaded a couple different analyses to this, and so I can click on which one I want to see. And this one here is my C file, which shows the same issue and gives me advice on how to fix it. I also did the same thing with my Java project, and here you can see it also detected that very weak password usage, which is cool because it realized that I'm using it as a password hash, which I don't even know how it figures that out, but I could be using a SHA-1 hash for a legitimate reason. Well, maybe not anymore, but so it's pretty cool that it was able to figure that out. And I think it's the last tool we're going to look at as far as source code analysis goes. This is something I just became aware of recently. GitHub recently purchased this company. They're integrated into their security lab. It's a pretty interesting tool in that it has a query language that it uses. So you can actually query your code kind of like you would query a database. It's pretty neat. And they actually have a bounty program. If you can write a query against one of the projects that there's a lot of open source projects that are using this already. If you can find a vulnerability of a certain level, then you can get a reward. So it's pretty neat. Now they've taken and they've created a whole bunch of queries for you that you can then run against your repository in the same way as these other things work. Again, simple link to GitHub, not surprisingly. I'm not going to probably show you this one. This is the query language. You can kind of see there at the bottom. You can compile it and run it against your repository. I'll just skip ahead to the actual demo of the full tool. So here again, we have a project overview. one nice thing about this is it can actually compile the code for you. So there's other tools I showed you have to run a offline tool against your compilation project. This, if it can compile your code, it will do it for you, and it'll do the analysis on its own. So again, this is those Python, same Python files. You can see it's discovered similar vulnerabilities, but it's done in a completely different mechanism than the other tools did. So definitely another one to consider adding to your arsenal. Oh, one thing, this does not support as many languages as some of the other tools do. So definitely, see if it supports the other languages you're interested in. And again, to quote this guy David, I like his writings. No one tool solves all the problems, so definitely use as many as you can. And these are not an exhaustive list of tools, or you can find on the NIST website a whole list of static code analysis tools that are out there, commercial and otherwise. So take a look at that. Okay, so moving on. So like I said earlier, the other thing that's really crept up is the component dependency management. This has traditionally been a real pain to deal with, but there are some good tools now that are available open source that you can use to keep on top of these. Here's a whole list. If you go on Open Web Application Security Project, great website for all your security needs. They have a listing of various tools you can use. GitHub also now has this dependency tracker. It's been around for, I guess, a little bit. If you have a language that it supports, like Java, for instance, and you have a properly configured XML file with all your dependencies, then it will automatically do some cool stuff, like show you that you have vulnerable dependencies in your dependency graph. And if it detects a change in vulnerability status, you get a lovely email. You get an automatic pull request if you want to do the update, and it gives you a remediation pull request for you automatically. So if you have a language that supports this, there's no reason to not use it. Okay, I forget sorry, I was carried on from the last one. Okay, the other one is this OWASP project, a dependency check. This is another cool tool that it's free to use. It's a command line tool. You can also integrate it plugin-wise into Jenkins, other CI environments. This one's pretty simple. It runs, like I said, from the command line. It looks at a directory, and it does signatures on all the components in that directory and generates a report for you, which is then in, what is that not? HTML report for you. It should load at some point. Well, anyway, you get the idea. It'll give you a report that you can then go back and remediate. On a little bit more complicated side, they also have dependency track, which does a similar thing, but it's a little bit more involved. This uses the concept of a software bill of materials, and it kind of provides you, like, if you're managing a whole lot of projects, or if you're a company, for instance, you can use this. It's provided as a web service that essentially kind of gives you an interface to upload a bunch of different project software bill of materials to. Now, one thing you do need to do is create a BOM. It supports Cyclone DX and I forget the name of the other one. So essentially, they're trying to standardize kind of these formats in order to track all the licenses that you're using, all the different software components that you're using. So you create one of those files that basically has, as you can see here, hashes of my components, my dependencies, and once that gets uploaded here to the system, it'll hopefully give me a list of critical vulnerabilities. So it just searches through a number of databases for those signatures and gives me a report back. As you can see there, it's got 2 security vulnerabilities and it then gives me some details on that. So another cool tool, especially if you're looking to implement something at your company or for a large-scale project. And then, of course, lastly, leverage your friends, coworkers, strangers, everybody else that you can think of to do code review for you. All these tools, they do have false positives that need to be sorted through. They're not going to detect everything. They're not going to detect architectural flaws. So you do still need you need help. You need the code review process. There's really nothing better than to have a good code review done. And so in order to enable that, probably a lot of you are already using Garrett, but if you don't feel like hosting it or you're not hosting it yourself, one tool you can look at is GarrettHub.io. You can sign up for an account here. You can link it to your GitHub quite easily. And you can go ahead and once you do a pull request, it'll show up here and give you the ability to view what was changed and, of course, add comments to any line of the file that you want. And then if you have other people that have accounts on here, you can assign a peer review to other individuals. Another kind of neat thing for this tool, because a lot of projects use it, you can actually view any any open status project that's out there. So you can look at what other people are doing in their code reviews and kind of learn. If you're not really good at doing this, which clearly I'm not because my comments aren't very helpful, you can learn from what other people are doing just by kind of clicking through some of the other stuff. It's right in the interface. And that's it for today. I'm kind of shocked I actually got through all these tools. But again, not an all-inclusive list. There's a whole set of dynamic testing tools that are free to use. Again, I go to the Open Web Application Security Project. They have a good list of these tools. They make a couple of cool tools themselves, fuzzy and penetration testing, all that good stuff. So don't forget about that. And I don't think I have time for questions, but certainly hit me up. Do I? I don't think I do. Oh, I do. Wow. Okay, well, I do have time for questions. So.
We have time for a couple. 2 questions.
So you mentioned using peer review and your friends for peer review. Do you have any recommendations for places where people can learn how to do good, secure code peer reviewing?
So that's a real good question. I mean, one of the assumptions about open source in general over the years, right, was that people were peer reviewing it, right? All eyes makes bug shallow, whatever Linus said. And yeah, you're right. If you don't have the right person to do it, it's not going to mount to a hill of beans, right? That's a good question. I mean, getting your project out there and just asking people is, go on Twitter. You've got a lot of resources these days that we didn't have in the past. We can ask people to do it. And then when you another cool thing too, like these tools, these SCA tools, you can integrate that into the peer review process, right? So that can help focus the attention to certain parts of the code that maybe should be looked at further.
Do you have any recommendations on best practices for integrating this into a workflow, like daily or weekly, or however you manage that? Because both on the dependency analysis and on the static code analysis tools, in a corporate environment, certainly, which is where I've tested them, the number of false positives and the number of actual alerts when you first run this over a code base is just overwhelming. And it's sort of hard to know where to start. Do you have any sort of recommendations for how to bring it up to the right level? Yeah,
that's a really good question, actually. Yeah, I kind of skipped ahead for my Coverity video there, but I ran it against the OpenSSL code base too. And it generates, you can imagine, a whole ton of potential vulnerabilities. So if you're dealing with an old code base, you're right, the process is really difficult. It's much easier if you're starting from scratch and you get the developers to run the tools on their own, and then also integrate. If you're using continuous integration, you can script these tools to run automatically. Like I said, if you're using GitHub, you can tie it in so when there's a new pull request that it automatically will run the tool. So you have a lot of options now, and it's best to just kind of kick it out as quickly, as often as you can, like during a development process. I say before you even submit a PR, run a tool on your own and see what you're going to get, right? But when you're dealing with an older code base, you really have to go for each one, and then you got to manually figure out if it's a problem or not. And then you can actually, all these tools, pretty much you can add an exception. They have different directives that you can add. On Coverity, they call it a model file. And then you can start getting some of those false positives out of the way, at least, So it's a kind of incremental process. But there are a lot of options to integrate these into continuous integrations. That's probably the best way to do it, for sure. Basically every nightly build, run a report. Somebody should look at it the next day and try to address the issues that are found.
Okay, please give a round of applause for Jason.